Here we are going to find electric field at 2 points A and B. A point is outside the sphere of radius r and B point is inside the sphere of radius r. But in this sphere, which is non-conducting, the charge is distributed as rho is equal to rho naught by x, where rho naught is a constant. So here we can see that the distribution of charge will not be uniform. The charge will be varying with distance x from the center. So as you go away from the center, the distribution of charge will become lesser, and near the center the charge will be intensely distributed within this non-conducting solid sphere of radius r, right? So let's say if I have to calculate the electric field at this point A, let's say electric field we have to find at point A, right? So in this case what I'll do is I'll simply calculate the whole charge of this sphere, and then I'll simply use k q total upon r square, k q total by r square, right? So how will I find the total charge of within this sphere is using integration. What I'll do is I'll simply make a shell kind of a thing at distance x and of thickness dx, right? At distance x of thickness dx, this is the thickness of this, which is dx. So what is the volume of this red colored spherical region? I can simply state that the volume of this spherical region will be area of this spherical region, which is 4 pi x square into dx. So this is area into height, which is the volume of this this spherical shell region, or you can simply find this volume by using 4 by 3 pi x plus dx cube minus 4 by 3 pi x cube. This also you can find this volume when you will use this application, or you'll calculate the volume using this relation. What you'll have to do is you'll have to use binomial theorem at the end to get this result. Finally we'll be getting the same result, 4 pi x square into dx, right? So if I multiply this 4 pi x square into dx with the density which is rho naught by x, and if I integrate it from 0 to r, then what I'll get is I'll get q total of this hemisphere, or this sphere, sorry. So x is getting cancelled with this x, 4 pi, what I get here is 4 pi rho naught x dx integration from 0 to r, 4 pi rho naught, and here I get r square by 2. So this is q total. And now if I have got this q total, then I can simply find electric field at A to B, k q total, which is 4 pi rho naught into r square by 2 by distance of point A. It should be r a square. So distance of point A is ra, so k q total by duri, which is ra ka square. So this way I can see that the answer is rho r square by 2 ra square and simply epsilon naught. So this is the electric field at this point, which is at distance ra outside the sphere. Now in B part, if I want to find the electric field inside, electric field at point B is inside, then what I will do is simply I will just calculate the charge carried by the sphere only up to this region. I will simply calculate the charge only up to this region, right? Up to this region, which extends up to r b distance from the center. I will just calculate this charge in this case now, this charge only, right? This complete charge. So in order to find this charge shaded blue, I have to just replace my limit from 0 to r to 0 to RB, right? So what I'll get here is simply 4 pi rho naught into RB square by 2. This is my charge Q total. Yeah, Q dash is better named. So electric field at B will be KQ dash, which is 4 pi rho naught into RB square by 2. KQ by Duri, which is RB square, RB square. So K 4 pi rho naught by 2 or rho naught by 2 epsilon naught. Rho naught by 2 epsilon naught. So this will be the electric field due to this this is sphere of variable charge having charge density as rho is equal to rho naught by x, and this will be the electric field inside the sphere at distance RB, right?